So this is one of a two-part video, and it's about something called reverse Polish notation and a data structure called the stack. Now what really inspired this video was an idea called the 10,958 problem or conundrum. Using the digits 1 to 9, if we put them in order, and simple mathematical operators like add, subtract, multiply, divide, we can make any number between 1 and 11,111 except for 10,958. So it might be something like 1 plus 2 plus 3 plus 4, all divided by 5, add 6, add 7, times 8 plus 9. And you can make any integer between 1 and 11,111 except for 10,958. We looked at this and whether it was possible to write a program that would test, was there really no combination for 10,958, because it looked as if the guy who had worked this out originally had used pen and paper, which is really, really impressive. But we thought maybe we could work it out computationally. Now, I'll share a link to a Matt Parker video where he talks about the problem and goes through like paper copies of all the solutions that the guy had worked out on paper. But we thought, well, we could write a program to do that. This was before I was a teacher. It was when I was a PhD student, and I looked at what was the best way to write a program that could do this. And actually, it was a little bit tricky. And I settled on using something called reverse Polish notation and making a reverse Polish notation calculator. So what is reverse Polish notation? Well, I've got what we could call an infix expression here. And by infix, I mean that the operators are in the middle or in between the operands, and operands are the numbers. This is a normal, everyday way of writing an equation that you would see, that you might write in your maths jotter. I've got 1 plus 3 in brackets, so that must be 4 times 5, so 4 times 5 is 20. This is the same expression written in reverse Polish notation, and it's called a postfix notation. And postfix means that the operators are post or after the numbers, the operands. So in this case, instead of 1 plus 3, it's 1, 3, plus, meaning that we take the 1, the 3, and then we do the plus operation on them. And for the next one, we've got that 1, 3 plus has already been worked out, that's 4, 5 multiply, meaning that we take the 4, we times it by 5. So this is what's called reverse Polish notation. And you might think, why would I do that? Because it seems a really strange way of writing something out. Well, it is. It's not natural to us because it's not something that we're used to seeing, but actually it makes a lot of sense. It's a way of writing these expressions without using brackets. And that's really important for this 10,958 problem. If I want to slot in different operators and try like 1 plus 2, 1 minus 2, 1 times 2, you saw in the initial slide when I'd put that up, there were lots of brackets in that expression. Now, if I've got to insert brackets as well, suddenly my problem becomes a lot more complex. It's also a bit less work for the computer to work out. There's a good computer file video on this. It's a little bit older, but I think it's a really good explanation. It's also a good explanation of the stack that I'm going to get to in a minute. If we want to store a reverse Polish notation or postfix expression and we want to evaluate that, he'll show how that actually works inside the processor in the registers. So you take the first value and you store it in a register, and then you take the second value and you store it in a register, and then you do the operation. As I've kind of alluded to, brackets are actually quite hard. They're certainly very hard to write an expression with brackets programmatically. It's also not all that easy to evaluate an expression programmatically. And before we can go into how the algorithm works, we need to look at a data structure called a stack. Now, when I say data structure, in National 5, you'd be talking about arrays or lists. In Advanced Higher, you would be doing linked lists, but there's actually lots of extra data structures that we don't do in the SQE courses. That's sort of things that you would do in a kind of first year uni course. And a stack, well, I'm not going to go into everything about the stack, is quite a cool data structure, but it's also vital for this algorithm to work. Now, you could think of an array as a long line. It's linear. We put these items in order, the elements in the array, and they're numbered. So you could get element 0, you could get element 5, you could get element 3, get whatever element you want out of the array. A stack isn't quite like that. Instead, in a stack, you can think of it as we're putting them one on top of the other. So all the values in the stack are getting stacked up, and we can only see the one on the top, and we can only really deal with the one on the top. When we put new data into the stack, it's called pushing it onto the stack. And when we take data out, it's called popping it off the top of the stack. And then we can see what was underneath. And then if we pop that, we can see the one that was underneath. And if we pop that, we can see the one that was underneath. How this algorithm works is we set up an empty stack. Then we loop through each of the tokens. And by token, I mean the 1, 3, plus 5, and the star. And then we've got two main rules. If it's a number, it goes on the stack. So I get the 1 goes in my stack, then the 3 goes on top of that, that's the next thing on the stack. And then I get to the plus. Now the plus isn't a number, it's an operator. So what we do whenever we get to an operator is we pop the most recent value, so we pop the 3, then we pop the 1, we do the plus, so 3 plus 1 is 4, and we put that 4 back on the stack because that's a number. So I'm going to show a little visualization and then I'll go over the code. If I take the algorithm step by step, and I've got my expression here split into tokens, the 1, 3, plus 5 multiply. So my 1 is a number, and the rule is that numbers go on the stack. So 1 is going to start off my stack. Then I loop through and I get to my next iteration. My next token is a 3. So that's a number, so the rule is that goes on the stack. And because of the way stacks work, that goes on top of the 1. And then I'm going to take the next token, and the next token is a plus. That's an operator. It's not a number, so it doesn't go on the stack. Instead, we pop the value from the stack. So I take my plus, and then I pop the most recent value off the stack, which is a 3, and I pop the value that was underneath it as well, which was a 1. And that, of course, gives me 1 plus 3, which is 4. So I put that result back on the stack. So because 4 is a number, it goes on the stack. Now I keep looping, and my next token is a 5. That's a number, so that's going to go on the stack. My next token is a multiplication sign. Now that's not a number, that's an operator. So I'm going to follow the same rule that I did with the plus. If I pop the most recent value, and then I pop the value that was underneath that, and I'm going to end up with 4 times 5, which of course is 20. So I put 20 back on the stack, because 20 is a number, and I've now got to the end of my loop. I don't have any tokens left, and I've only got one thing on the stack, so that's going to be the answer. That's going to be the result. I'm going to show you how this looks in Python code. It's actually a fairly short piece of code. Now, originally I was going to go over the full code here, but to save a little bit of time, I'm just going to briefly go through it and give you a link instead. So you can see up the top, we've got the empty stack. It's just like a list. In fact, in Python, it's the same syntax. Then the expression here, so this string is what you would change if you were putting in your own RPN expression that you want to evaluate. You can try changing the numbers in there, see what you get. Then I'm looping through each token. If the token is one of the operators, then we push it onto the top of the stack. If it's an operator, then we pop the most recent value and then the value before that off the stack, do the operation, and we put them back on the stack. And at the end of it, after the loop, we'll only have one thing left on the stack, so that will be the answer. Now that I've shown you the code and I've given you a link to it, there's some changes that you can try and make into it. First of all, just to start off simply, the code that I've given you only works for the add and multiply operations. You're going to want it to work for division and subtraction as well. First of all, see if you can get those. Then can you add the power of, like x to the power of y? In this discombobulator program that looks at the 10,958 problem, we had to use powers, 1 to the power of 2, or 2 to the power of 3, or 3 to the power of 4. We also used concatenation. And what I mean by that is string concatenation that you're used to as a programmer. So if you took, say, 2 and 3, instead of that being 5, if you concatenate them, it becomes 23. Or if you take 4, 5, and 6, it becomes 456. How would you implement that in this program? It would just be an operator like any of the other operators. Maybe use an and sign. It's up to you what symbol you want to use in your string. And if the token is an and sign, you're going to want to convert your integer to a string, convert the other integer to the string, concatenate them as strings, then convert that back to an integer before you put it on the stack, because if you don't, you're going to get an error, depending on how your programming language deals with different data types. And then we want to see, can you make an RPN, reverse Polish notation calculator, a program that takes an expression from the user, so asks the user to type in their expression, and it evaluates it using reverse Polish notation. And we could assume that it's going to be valid. If you really want to try and write an input validation for this, you can, but you're going to find that quite tricky. So if we just assume that the user types in a valid RPN expression, can you evaluate it? And can you do it with all these operators, with add, subtract, multiply, divide, x to the power of y, concatenation? Can you add real numbers to it? This program at the moment would only work for integers, and actually if you did something like 7 divided by 2, it would get that result as an integer. And if you know about this from higher and how we convert between floating point to integer, actually it wouldn't round it in Python specifically if you're using an int. function like we are in this code, it would just give you 3. So can you fix your program so that it would work with real numbers as well? And then what else can you do with this? Can you even maybe start to have a look at the 10,958 problem? Can you see maybe if you pick a smaller number so it's easier to do on paper, or you pick one of the examples that I used earlier in this video, like 127, can you write a program that will evaluate different expressions trying to find it? And then how does it work? Do you substitute in those systematically, or do you do it kind of randomly? Do you generate a random number, and if it's a 1 you do a plus, and if it's a 2 you do subtract, and so on? Now, I'll go over the code in a separate video for this program that we wrote that did it. The program ran over days and days, running overnight, because it was doing every integer between 1 and I don't even think it was 11,111. I think we went beyond that. We went to bigger numbers, and we couldn't find any solution to 10,958 without sort of cheating, like inserting a decimal point, so maybe you had 2.34 or something like that. I'll go over that in a separate video though.